Have you ever imagined having dinner at home made completely by robots? Are robots going to farms and picking fruit and vegetable? I'm Atif Syed, founder and CEO of Wootzano Limited, and I'm going to show you how all of this is possible right now. One of the issues with robotic systems, robots in general, is robots trying to do manual dexterous labor. So robots trying to pick up delicate objects in a dexterous manner. Now, if vision or cameras on its own, if they are the only ones used, vision on its own can be obstructed. Vision cannot tell properties intricately. And more importantly, vision can only see the front side, will not give you the full picture. Now, when I look at this particular object, I identify with my own eyes. I know what this object is, and then I feel it with my skin. I know the temperature, I know the roughness, I know how heavy it is. And based on all this information, I know how to manipulate this object. Now, if you want robots to do exactly the same kind of manipulation in a dexterous manner, we need to create something akin to human skin. So that's exactly what we did. So we have created a completely ultra-compliant skin, electronic skin, which is pretty much a sample, still a sample here, which is stretchable, bendable, twistable, and you can even crumple it, probably better than human skin, and regains its shape. You can fabricate electronics directly on top of it. So it's a highly sensitive force and pressure sensor, integrated with temperature, humidity, and actually goes beyond human evolution and smells objects it touches. Essentially has a nose. So it gives more information than what our skin does. So this is some of the images really for skin for hands. So some of it for human hands, some are for robotic end effectors. But we're not really limited to hands. We don't make skin only for hands. We make skin for robotic feet. So we not only allow robots to pick up delicate objects in a dexterous manner, we actually allow robots to even walk in a dexterous way, balance itself in a very complex environment. So there's some examples which I'm going to give in a bit in terms of how we utilize these technologies, how we're using it right now in robotic systems. So in addition to all of that, we use machine learning algorithms. So primarily at this point, we use humans in training data set to collect data of picking and grasping various objects. And then we use, at the moment, supervised learning. So we tell what's good, what's bad, and the robot pretty much follows it. And I'll tell you again why we're doing it in this way in a minute. So one of the areas we are involved in is putting our robots in pack houses, essentially picking up fresh produce like tomatoes and apples and so on. So with our skin, or with the robotic skin, a robot is able to grasp a tomato, know exactly how firm it is, so based on that it can know how ripe fresh produce is, and also it handles it in a way that it doesn't bruise the fresh produce. It's quite important to do that. And while it touches that, it measures ethylene signatures, and actually we can predict shelf life of a particular fresh produce while it's going in. So we can tell, the pack houses can not only package this autonomously, but also tell how long a fresh produce is going to last. And that saves a lot of money to the pack houses, and eventually gets fresher produce at home when you buy from supermarkets. The other application we are involved in is one of the world's first attempt to do fully autonomous, and there's just two extreme examples. The world's first attempt to do a fully autonomous maintenance, inspection, and repair of offshore wind turbine blades. So a quick example of this, this is one of a big project where an autonomous boat carries a bunch of drone scouting robots. These drones go on top of the wind turbine blades, monitor where the issue is, where it needs replacement or repairing, comes back, reports what needs to be repaired, and picks up one of our hexapod robots, which has our feet, our sensors on the feet. What it does, the robot then goes, grinds it, spray coats a weather coating, which is degraded, and comes back and repeats the process. Now, our skin, what it does is it allows a robot to know exactly what surface it's on. So imagine these are actually on North Sea. So you have a gust of wind coming in. One of the issues is apparently seagulls coming in and splattering on it, and you have blood all over it, bird poo, and lots of other surface environments where the robot needs to manipulate itself. So we actually tell how to manipulate, and the robot knows what to do, what not to do. Just two very, very weird examples, but the aim was really to show what we do. We are pretty much robot agnostic. We don't care what robots they are. So our aim and mission is to not stop until we make all robots, robotic systems, sense and feel like we do, and actually go beyond human evolution. We are also involved in putting these on prosthetic limbs, so allowing amputees to create a full closed-loop feedback system. So not only an amputee can understand and say, okay, I want to pick up an object, but they'll have an actual feedback from our skin, which doesn't exist. And one of the biggest reasons why all these things is the fact that this is electronics on a very, very compliant substrate. No one is able to do this directly on it because we have a patented technology, a proprietary technology, to create the polymer itself, which enables electronics to be fabricated directly on top of these substrates. And obviously we have a bunch of layers, like our skin, which adds functionalities, gives piezoelectric, piezoresistive responses to measure all sorts of feedback. So this is the team. We are quite a young but actually quite growing team. We're actually almost 12. We didn't fit in all the people in there. And we've started about a year ago, a year 3 months. We've raised over £2 million in funding. We have over 24 partners, customers, and we are integrating trialing as we speak. So that's pretty much it from my side, and thanks a lot. Any questions?
Very impressive. Robot systems beyond human evolution. Judges, floor is yours.
The commercial model is a licensing model for industrial partners. What is the business? And also, I got to ask, what's with the name?
Wootzano, right,
yeah.
Actually.
So go to business first.
So
and then,
I'll tell you both. So what we do right now, we manufacture the sensors ourselves. So we don't want, so essentially the sensor itself is manufactured by us. We provide the software, the machine learning, essentially the database, and we sell it at the moment business to business, directly to pack houses. Now, our customers at the moment, they're supermarkets like Ocado and so on, but also we have customers like pack houses. Some of the customers actually have robotic systems, so they have manipulators and effectors. All we do is we retrofit our sensors to make it more intelligent and do the task that they're supposed to. But some of customers, like pack houses, who never ever thought of going to this field and getting robots, they don't have robots. So we have partners. Actually, one of our partners, one of our suppliers for robotic system is in China as well. So essentially, for those customers, we source all these materials, put the system in, and they pay a price. So what we do at the moment is not licensed. We directly sell. It's an end-to-end solution. So the second part about the Wootzano. The interesting thing was wood steel. Not many people know about wood steel. It's one of the earliest known commercially available product which had nanostructures in it. So our product actually has lots of nanostructures, a lot of amazing photos around. and the ano is really an amalgamation of nano. And the biggest thing was no one had a trademark on it. So
can I just... cost, again, I don't usually focus on cost, but I'm really interested in how much cost saving can, like, for example, a pack house make? Like, so is it dramatic?
Yeah, one robot can replace 3 human workers on a pack house. So we at the moment, we're doing packaging of tomatoes for pack houses, and it's essentially 3 human workers can replace one robot. And on an average, with one human worker coming in, it's about 20,000 plus or minus pounds a year, and then people take sick leave. They probably don't turn up to work. The other biggest issue is just about a month and a half ago, we went to one of our customers, one of the pack houses, and they were supposed to get 95 temp workers. So they hire a lot of temp workers to do this manual picking, and only about 35 turned up. So they basically said this is an amazing example of what issues we face on a daily basis, because they were packaging for Waitrose and they had another customer who were wanting it immediately. So they actually had to take away the products from the other supermarket and give it to Waitrose and say, well, we're still having to provide to Waitrose, and how do we do it? So the issue really is fitting. What we're doing with robotic system is increasing productivity for these guys. They're able to make these robots work, in theory, 24 hours, but we're talking about 16 hours and a downtime.
Okay, we have time for one last question, a quick question and a very quick answer. Yeah. Thank you.
I know there are some public health concerns with nanoparticles getting into water streams and the like. Have you thought about this?
We did. So our nanostructures are fully biocompatible. They're non-toxic. Essentially, one of it is zinc you eat, so it's pretty safe.
Thank you very much, Wootzano. Thank you.